Okay, let's get started.
Okay, thank you everybody. Allah Hafiz.
Can you see my PowerPoint?
Yes, sir, we can.
Okay, I have already told about me. Let's tell something about computer networking's importance in ICT field. I hope that if you are entering in your professional life, maybe most of you will be interested to work in ICT field in different areas of IT, such as software development, computer networking, cloud administration, or architecture, cyber security, network or system administrator, even telecommunication engineering, and IT manager. In these positions,
Hello, sir.
your
Hello, sir.
future or career
Hello.
paths. So, hello, is there any problem?
Yes, sir. I want to ask a question, sir.
Yeah,
Sorry
sure.
for the interruption.
Sure.
How long is this course going to take? I mean, how many hours in a day? And how long, like in weeks?
Sorry, can you repeat the question again?
I mean, how many hours are we going to have the class in a day? Like how long?
About this training.
Yes, sir.
Oh, yes, it's 2-hour training per day, and there will be 15 sessions. Although this time period is not sufficient to cover, or however, if you have some basic knowledge, then it would be enough to cover. But regarding the schedule, I have one issue, that is, if it is possible to conduct the session in the evening, but I am not sure. Hello?
Okay, sir. So that means this session is going to take about 5 weeks.
Yeah. And today we will conduct 2 hours. After 1 hour, we will take 10 minutes break. Then we will again start.
Okay, sir.
Okay. Thank you. So I am talking about our computer networking knowledge development use in your future career. So I think as you can utilize this knowledge in several areas, so it is very important. For example, if you work with cloud computing, then networking is very relevant and is very important and applicable in every areas. And you will need this knowledge, at least CCNA level knowledge in virtual networking. All the concepts and the protocols are same. And if you work in cyber security field, then it will you will need this knowledge. Without knowledge of networking, you will not be able to succeed. If you work in telecommunication, even you know, telecommunications technology has gone through a convergence over period. It is now it's IP networking is used. It's as backhaul network of telecommunication, whether it is 2G, 3G, or 4G, even 5G. So there is also applicable. If you are if you work as a manager, IT manager in future, but at some point of view, then in that case also it is relevant, and you know the architecture and things. So it is important. So you should take it seriously as you are a student of CSE or relevant subject, Tripoli, for example, or other technical subjects. Okay. What is the role of network engineer or the specialist? Designing, implementation, and optimization of network. And you have to know the routing, switching, which is covered in this course, and also firewall. Firewall is not covered in this course, but you have a little idea about this. So these are the major areas of activities of a network engineer or specialist. So how can you develop your networking knowledge? So you know, you have to study extensively to gain some knowledge. You have to collect different literature from different sources. You can study your books. Your academic course are also source of some networking knowledge. So vendor to get vendor specific knowledge, you have to read about different study guides from global network manufacturers such as Cisco, Juniper, Microtik, etc. To get vendor specific. From your academic study, you will not get vendor specific knowledge, because academic study mainly focus on theoretical part. So you have to study different things, and also you have to gain some hands-on experience through internship, through personal study, or working in a lab environment, or which is very easy to deploy a lab environment on your PC or any computer. And another way of learning is professional training and obtaining professional certifications. So if you try to obtain CCNA, for example, or other comparable certifications, you can you will be able to gain with this knowledge, because there are some employers around the world who prefer the CCNA or equivalent certifications from new entrants. So it will be a good step for you to gain certification. So what are the network vendors globally work to develop networking devices or services, different softwares, for example. Cisco is the global leader, then Juniper, Huawei, Dell, Arista, Microtik, to name a few. There are many, so many networking device manufacturers in the world, but I deemed those just to get some examples. And among them, Cisco is global leader in terms of knowledge development also, because they have so many study guides, books that can help you to get real life, real life knowledge, which can you utilize in your career or job life. That is why I think CCNA course is a great choice for you to enhance your knowledge. I think it is a good start for you. From this course, what you can learn. So network fundamentals, I have already mentioned network access. How can we access network? IP connectivity, IP services, security fundamentals. Security is very important right now because cyber security has become business critical globally. So it is an important area. So whenever you study anything like software development, like cloud or whatever in the IT, you must consider security aspect. Otherwise, it will be breached and it will hamper business in some way. And another area is automation and programmability. So right now, everything is becoming automated. So automation is on focus because we have to perform so many tasks. Without automation, it will be impossible for us to do anything. So, for example, if you are working at a very large data center or network where there are hundreds or even thousands of servers or networking devices, router, switch, then if you want to configure one by one, and then it will be a daunting task. In that case, it is tough for everybody. So automation comes here so that we can configure in automated manner. And programmability, we can use some programming knowledge. You may have some knowledge in C, C++, or other programming languages. Python, for example, which is commonly used in networking. So that is why automation is also covered in this CCNA course. In CCNA, there is certification tracks. CCNA is starting certification track, then CCNP. CCNA, the elaboration you know about, I hope, Cisco Certified Network Associate, then is upper level track is Cisco Certified Network Professional. It is professional level certification. They have different areas of focus, major areas, which are actually collaboration, data center, enterprise networking, actually, in fact, security service provider, and then CCA, Cisco Certified Internet Network Expert. So these are the track. If you take those, but you can and think about those areas. So up to now, do you have any questions or any clarification? Hello? Hello?
No, sir.
No, sir.
Everything clear to you, or thing that is unclear, or not understanding anything? I think everybody should speak, at least whether, or to prove that you are at least present in this session.
So we are present, we are understanding
Yeah.
everything.
Great, great. Then tell me about your reaction, whether you understand things or find it different, or any issue. Okay, I think
Sir,
any problem in understanding of this?
sir. Hello, sir.
Yeah, I can hear.
Okay, sir. Sir, what is the abbreviation of CCIE?
CCIE actually is Cisco Certified Internet Network Expert. It is expert level certification. If you can obtain this certificate, you will be the guru of networking, and it is highly recognized globally. Okay, network. We just cover some terms. You know, LAN 1, WLAN, main, PAN, internet. This, you are, I think, familiar with these terms. Do you have any questions with this? Do you have any? না না না, ওটা তো আপনি জানালেন না, ওই যে জিনিসগুলো হবে না, ওটা আচ্ছা কিভাবে বললেন? আচ্ছা ঠিক আছে, হ্যাঁ জানাই দেন। হ্যালো, do you have any question or anything regarding different types of network?
No, sir.
So
Okay.
we have some knowledge about this kind of network, but still
Okay, great. That's great. So I don't need to discuss further. Okay, let's talk about TCP/IP networking. Just from historical perspective, you know that in early 80s, when networking concepts or protocols are developing, there are different proprietary protocols. For example, IBM had some standards or protocols. DC had another protocols. So they had different protocols, and they are not interoperable, or it was very difficult to communicate between their system. In 1990s, also the same scenario, but over periods, everybody moved to open standards, open standards are globally accepted standards. They are developed through collaboration and approval process through international organizations like ISO, for example, International Standards Organization. So, so another organizations such as NIST, National Institute of Standards and Technologies. And these are the organizations that are involved in developing different protocols. For example, IEEE, RFC, different organizations, task force are involved. So they develop a common protocol that can be adopted globally. So it is TCP/IP. So you know TCP/IP protocol. It has different layers, network. So why we divide the protocols in different conceptual layers? Because it is easier to understand, easier to develop, easier to troubleshoot, and vendors can develop using those layers so that they can interoperate with other vendors' equipment. Right now, we can use Cisco's network, Microsoft's operating system, or other vendors such as Dell's or HP's laptop or server. They can interconnect without any problem because they follow open standards, same TCP/IP networking model, and the specifications specified in different layers. Okay. Then Osi Reference Model has 7 layers. You know that there are some differences in TCP application layer from upper layer, from session presentation application, they call this application, and in this model has some differences. If we compare them, you already know, I hope. This is a comparison just two. So how these protocols layers are used? So in communication, we can think that each layer is communicating with each layer. For example, a sending device, a physical layer is communicating with receiving devices in plain knowledge, just to understand. So although we know that when we talk about upper layer, for example, application layer interacts with our application in the system or computer, which gets the data, then it is going to the presentation layer and in present different formats, which we'll discuss later. And then it will go to session layer. Session layer add some header or additional information or bits, and then it goes to transport, then network, then data link, then physical layer converts just bit level, and it transmits in transmission media in the form of electron or photon or electromagnetic wave, depending on the media we use. On the receiving side, and physical layers data transformed to data link layer as frame, then packet will transfer to segments, then data will discuss further. So upper 3 layers is known as upper layers, 3 and the layer 1 to 4 is known as lower layer. As a network engineer, for example, we have to work with all the layers in one way or the other part. But from 1 to 4 is most common for a network engineer, because router works in network layer, switch work in layer 2 data link layer, and those two devices are most commonly handled on a day-to-day basis by a network engineer. So let's give some example about what the protocols that are used in different layers. If we talk about layer 1, we use different media. For example, we use Ethernet cable, which is copper cable, and so it is when we use RJ45 connector and cable, and then we use optical fiber in some cases. Then we use radio link, Wi-Fi. So these are the physical layer connectivity for networking. And then data link layer protocols are Ethernet, PTP, point-to-point protocol, frame relay, etc. And networking layer, you know, IP version 4, IP version 6, and different routing protocols such as RIP, OSPF, PIGRP, etc. In transport layer, 2 protocols are mostly used, Dhcp and UDP. We'll discuss them in details. In session layer, there are some session layer protocols, such as session initiation protocol. For example, in IP telephony or VoIP, this protocol is used. And in presentation layer, there are different standards, such as CSP, and for pictures format, for example, JPG, and these are some formats used in presentation layer. Because every application data has a specific format or application specific characteristics that is used in presentation layer. In application layer, we know that HTTP for web browsing, HTTPS for web browsing, for secured web browsing, and DNS, DHCP, you know everything, I hope. Okay. Then in brief, what are the functions of 7 layers? For your practical life, I think that these 7 layers must be clear to you to understand different networking technologies and to work with them. So physical layer is just used to transmit bit stream over physical medium, which I already mentioned. Mostly we use 3 medium. In a sense, 2 medium, just cable connected media cable, just direct cable, or another is wireless, which is Wi-Fi, for example, or high capacity radio link is also used. In cable connectivity, there are 2 types: Ethernet copper cable and fiber optic cable. And then data link layer is format of data on the network. It is it converts bits. Physical layer, we have bits. It is bits. A group of bits can form frames, and those frames are then packaged into converted into network layer packet, and this way we have upper layer data. Okay, if we talk about different devices that work at different layers, for physical layers, what are the device of things there? Physical layer, there is difference. For example, cables are working in physical layer. There are hubs. Hubs are not used these days because it is not efficient. And repeaters are sometimes used when it is long distance for long distance transmission. At some point, signals get attenuated to regenerate the weak signals. Repeaters are used. Modems are used in some way, but in early days, for example, around 10 to 15 years ago or more, modems are widely used because people use telephone landline for internet connection or cable TV line for internet connection. They use the cable modem just to convert. And then in data link layer, bridge and layer to switch work at data link layer, and we have mentioned that routers work at network at layer 3 or layer 3 switch. You will learn that layer 3 switch, although switch works in layer 2, some switches have some routing capabilities. So that is why they call layer 3 switches. Actually, switch is layer 2 device. And in upper layers, the firewalls work at different levels. Actually, firewall works at layer 3 and 4, 5, 6, 7, and all layers can work, even sometimes layer 2.
So
do you have any question up to now?
yes,
Yeah.
sir.
Yeah.
Yeah, which layer does the hardware firewall operate?
Hardware firewall.
Yes, sir.
Yes, okay. Hardware firewall, actually firewall found in 3 different formats. One is hardware appliance, then virtualized, and another is cloud based. Whether it is in virtual or virtual cloud or physical, the work more or less the similar way. A hardware based firewall is actually right now actually work in layer 3, 4, 5, 6, 7 because the firewalls we deploy out now that are called next generation firewall. Next generation firewall have different capabilities. They can work at layer 3, layer 4, and 5, 6, 7. In all layers they can work. Although there are other different subcomponents in firewall. For example, just packet filtering firewall, which are available in router also. We'll show you in this course. We will just filter network traffic using layer 3 IP address and port based filtering. It is just packet filtering, and we have deep packet inspection, which works in application layer. So firewall works in all these layers, whether it is physical appliance, virtual or cloud. It's clear?
Yes, sir. Thank you very much.
Okay. Do you have any question? Any other question? Probably not. Okay. I already talked about proprietary and open standards. Very important question. And why industry moved from proprietary to open standards? Because proprietary standards are developed by a company or vendor, they develop their system, and their devices or systems usually not interoperate with other systems, or we need different techniques to ensure communication with other vendors' device, which is difficult. So people move from proprietary protocol. So, for example, Apple Talk was developed by Apple Incorporated. In earlier days, they use this networking protocol, but right now it's not applicable. Apple's devices, iPhone, for example, or MacBooks, or their products use TCP/IP protocol. Otherwise, they will not be able to communicate. Open standards had different benefits. As I already mentioned, interoperability is very crucial, and widespread adoption. Different companies use the same protocols, which is easier. And another benefit is for clients' perspective, we can use multi-vendor deployment. If we deploy a network, we can purchase different devices from different companies. For example, we can purchase routers from Cisco, switches from, for example, Juniper or Huawei. It's no problem. And they facilitate modular engineering. Modular engineering means you can change a specific component. For example, if everything is okay, everything is unchanged, you just change IP layer. For example, if you use IP version 4, you just want to IP version 6. Just you want to transform your network to IP version 6. So you work in this networking layer on. Other layers are unchanged. So it is modular engineering. And then accelerate evolution, which means that technology is always evolving and it is improving day by day. So we see that one layer is improved and another layers are unchanged, and then another layer is changed. And eventually everything is improved. For example, we see that cables in physical layer, cables are improved from Cat 6 to Cat 7, which has greater capability, or everything is unchanged, we just change network interface card. So it is enhancing resolution. Okay, we can get further in different layers. Let's start from top layer. Layer 7, which we experience every day. When we browse some website, for example, we just connect to a server somewhere, and this server we communicate over in network. So we use HTTP or HTTPS for web browsing. Just it is layer 7. it is what is the purposes of layer 7? Layer 7 used by end user software, such as web browser. So we have web browser or email client on our computer, and each has some connection with TCP IP stack of my computer. TCP IP stacks, layer 7 is connected with this application, and other layers, internal communication are happening. So what are the layer 7 protocols? You have to memorize, not memorize actually, just have knowledge about this protocol: HTTP, HTTPS, DNS, DHCP, SMTP, POP3, IMAP, FTP, TFTP. These are the some protocols commonly used. For example, SMTP, simple mail transfer, for mail transmission. For mail receiving, we use POP3 or IMAP. IMAP is mostly used. Do you have any idea about DHCP? Can
Yes,
anyone
sir.
tell why?
Yes, sir.
Why do we use DHCP?
To dynamically assign IP address to the client and also other information regarding
Okay.
their network.
Right. Okay. Okay. Let's see. We got some messages. Okay. Okay. You know about. Can anyone tell about me FTP? Why we use FTP?
Yes, sir. It is a file transfer protocol that allows us to download file from a server.
right.
FTP server.
Yeah. Okay. Do you know about TFTP? Anybody? Although it is uncommon, it's not commonly used.
Yes, sir. It is an update of FTP, trivial file transfer protocol.
Yeah, correct. Trivial use it is used in some areas where very small file is transferred. For example, TFTP can be used to transfer some configuration file, for example. For example, in Cisco IP telephones use TFTP. When the phone is powered up, it gets configuration file from the server, and with this configuration, it establishes network connectivity, for example. Anyway, I see that you have some knowledge about this networking. It's great. That I think you should enhance from here. Okay, then we have presentation layer. Our presentation layer is just how to present those application layer data sources, how they are encoded, encrypt, or compress those application data, and they encode. For example, sending device, they encode, encrypt, and compress data. And for receiving device, they decode, decrypt, decompress data. And some format I also mentioned, Osi, for example, for coding, JPG, G, different formats are used. In layer 5, it is session actually, and to session, establish session between two applications, for example. For example, your computer is connected to a web application. So with web application, and it establishes a session application to application session, and then maintain it until the communication ends. And then layer 4, it is a transport layer. From networking perspective, we have to work extensively in those areas. Although upper layers, we have to understand, but we work little. For example, in session layer, we usually have nothing to do. For example, it's ASCII format. This application is doing this, or software developers have some code for those activities. Network engineer has little to do, although for advanced activities in firewall or other cases, they have to look in those areas for different issues. But usually, a network engineer, a specialist, work between layer 1 to 4, extensively used, and have to work in everywhere, and you will see these in future or in our course also. So transport layer is very important to understand in great detail. So transport layer takes session layer data and when it converts it or breaks it in session segments, for example, segments converted, or in for receiving case, it takes packets from networking layer and converts it with higher level data format or protocol data unit PDU. Okay, what is the roles of this transport layer in networking? It has different roles such as flow control. Sometimes network has to dynamically adjust the transmission rate for different reason. Transmission media can be congested, can be disturbed. In that case, it has to dynamically control transmission rate, or sometimes reduce, or sometimes they increase the transmission rate. Okay, it's one. Then error control. In this layer, it is checked the sent message receiving improperly. If not, it will request retransmission. And so another role of this layer. And when we send a message or data or information to other machine and address, we have to use source address, we have to use destination address. So addressing issue also comes here, although we don't call it address, we just call it port. Porting is also identifier, the source of a session, I would say. So we use ports when we initiate a communication. We use TCP and UDP ports, and we have different ports, 0 to 65,535. we use those code as originating, and we use some target service. For example, if we send to HTTP server, HTTP server has 80 port, which is a well-known port, and we will use 80 as a destination port. 0 is reserved, 0 is not used. That is, we use another ports. And for UDP, source is optional because there is no feedback from receiving end. Okay. When we initiate a communication, and we get one thing, that is TCP/IP handshake. TCP/IP is a reliable protocol, we say. On the other hand, UDP is called connectionless and not reliable. So TCP is connection oriented protocol. Why it is connection oriented? Before sending the message or actual communication data, we have to establish a handshake. How it is established? For example, client machine just send a sync request to server. Server another generate acknowledge, server acknowledge this sync, and also server initiate a sync. So it sends a sync plus acknowledgement, synchronization plus acknowledgement request. Then client will send a acknowledgement. Then communication channel is established. If the handshake is not established properly, communication is not possible in TCP. So I also elaborated here. One thing is different in this case is sequence number is added in sync request, and with this receiver are acknowledged just it increment +1. It is a important issue. For example, in firewall. Firewall, if we establish some firewall, they check this sequence. If you send a sequence number 5 and receive acknowledgement sequence number, for example, 15, it will not be accepted. So it is important. UDP is some other important concepts are there in TCP. TCP is reliable message delivery because there is acknowledgement. You send a message to some device, and the receiving device will send a positive acknowledgement. Then you are certain that you are your message is received, and you will send another message. In this way, reliability is ensured. On the other hand, in case of TCP is UDP, user datagram protocol, there is no acknowledgement because in this protocol, no overhead is allowed. In case of TCP, there are this is an overhead. Overhead is additional communication. For example, acknowledgement is received, then you are sending it, acknowledgement fails, then you retransmit. That is, it is additional additional latency will be added to the communication. But in UDP, it is just, it assumes that link is reliable. Whatever I am sending to the receiving device, it is receiving. It is assumed. Although in practice, there are some packet loss or some drop. So another important concept in Dhcp, just I talk about how data rate, transmission rate is adjusted or changed depending on transmission mediums, condition or congestion. And so here is one concept, windowing. We know that in TCP, whenever we send a segment to other device, we wait for an acknowledgement, and after acknowledgement, we'll send another new message. If we send one message and wait for acknowledgement and then on, it would not be efficient. So here there are some flexibility. We send, for example, 2 or 3 segments. Then we will wait for acknowledgement. Then we will get acknowledgement. Okay, got your 3 segments. Okay. Then we in subsequent transmission we will send more segments before receiving and another acknowledgement. In this way, it is bit rate is higher and it is efficient. But when there are some issues, then we then it is adjusted and send lower number of segments. So it is window size change depending on congestion and of the media. So it is this concept is windowing. It is done by TCP layer. So it is an important concept. Okay, up to now, do you have any question or any issues?
Yes, I have a question.
Yeah.
So despite the benefit that the TCP provided, why does the application developer sometimes prefer to use UDP over TCP?
Sorry, quite unclear. Can you speak a little louder?
Yes, sir. I said that, sir, despite the advantage that the TCP provided, why does the application developer sometimes prefer to use UDP over TCP?
Yes.
Because we know that TCP is connection oriented and UDP is connectionless protocol.
Yes, it's an important question, and you will encounter this question in different phases of your professional life or other places. It is important issue. TCP is connection oriented. In this process, sender needs to wait for acknowledgement, and it adds some latency and overhead to the system. It is less efficient, although it is reliable. On the other hand, UDP just send the messages or segments, or use a datagram. In fact, segments is not called in terminology, and assumes that the link is reliable. So when should we use? Some applications are very sensitive to latency. For example, voice, video. In those cases, if we send a message and wait for acknowledgement, then it will add some latency and user experience will be bad. That is why some latency sensitive or high volume of data transmission case, for example, video, for example. So in its video streaming, we have to send large volume of data, and it is also latency sensitive. In that case, we have to use UDP. In case of voice call, we have to use UDP. UDP is in that case efficient, although if link is not reliable or sometimes packet or data is dropped some way, in that case experience will not be up to expectation. So that is why we use UDP, although it is not reliable. And this is the okay, clear?
Yes, sir. It's clear. Thank you.
Okay, do anyone else has questions? Or you can add more points if I skipped somehow. In that case, others will be benefited if you can identify that this point should be included or should be discussed. You can add. I think this session will be helpful for you if it is interactive and full of discussion from everybody. Everybody can learn from everybody. For example, someone may not clear about the concept of the topic. In that case, if you add a point, then it will be good. Okay.
Sir.
Okay. Yes. Osman, maybe.
Yes, sir.
Osman,
Yes,
okay.
sir. I need more explanation on this slide that you are showing now.
You need more explanation
Yes,
regarding
this
which
this slide that you are showing now.
windowing.
Yes.
Yeah, windowing is a technique used by a transport layer, especially TCP protocol, is to adjust transmission rate. From your experience, you know that when you browse on your computer, you will experience that sometimes it gets a higher bandwidth, sometimes it is very congested, the page is not loading properly, you experience. So how a device, your mobile device or your laptop or tablet, whatever, can adjust with this issue. Actually, when our device send different segments, for example, it sends 2 segments, then it gets acknowledgement. Okay, it assumes that okay, good. I sent two segments, and then got acknowledgement. And now I can send 4. Then I send 4 and get acknowledgement. Okay, then I can increase further, depending on algorithm set in this system. So I assume that it is successful. So at some point, I will get I will not get acknowledgement because it reached too high for the medium, or some due to some congestion or other issues, and this traffic is dropped. So this time I will send lower number of segments. So with more segments means more data, right? So in this way, we adjust. Our system adjusts with data transmission rate and bit rate varies. So I know we know that when we use internet, internet or internet communication, whether in internal or internet, we experience that data bit rate are not equal all the time, right? And they are varying to some extent always. So this is the mechanism. Clear right now, Usman?
Yes, sir. It's clear. So it doesn't send the acknowledgement for each and every single segment.
No, single. Yes, single. If we send one segment and wait for acknowledgement, and then another one, it is not efficient. Although it is highly reliable, but it is not efficient. So we have to compromise. We have to send several segments at a time to get higher bit rate. But to doing so, we will vary some bit rate. Okay.
Yes, sir.
Okay. Can I proceed, or do you have any questions or any clarification, or you have anything to add in this discussion? I encourage you to discuss so that everybody can learn from your discussion, or everybody will be encouraged. I would like to ask you a question. Are you in the last year or final semester of your course, or somewhere other semester?
So there are two different sections attending this internship. One from the final year student and the other from the batch 18, which will be graduating in the coming year.
So I am not clear. Are you in the final semester, or?
Yes, sir. Some students are in their final semester, while some are not in their final semester.
Okay. Okay. That is, you are going to complete your bachelor degree. You are all from undergrad class, right? Or is there anyone? Yeah. Okay, great. You have some knowledge of networking from your academic study. It's correct. Okay, let's proceed. Osi reference model. TCP, yes, in TCP it has a format. So it for every segment it has an identifier. Say source port. Here you see the format of TCP segment. This header will be added with the packet received from. It will be added. It will added to the data received from session layer. From session layer, it adds source port and destination port. Can anyone say what will be the source port? What will be the destination port? Can anyone? Or you can try. Okay, let me tell. Source port would be anything randomly, just to identify the transmission. And destination port is fixed. Destination port is server port. For example, not server actually, service port. For example, you are accessing to a mail server. Mail server use which protocol? SMTP, simple mail transfer protocol, for example, or IMAP for receiving case. So in that case, we have to use a specific word. So let's give example of HTTP. HTTP service use port 80, for example. So in that case, destination port will be 80. It is unchanged, but source port will be any ephemeral, which is an ephemeral port. Ephemeral port means is very is used for is actually used for one time for this session only, and for other session or other transmission we will different port because it is ephemeral. It has no long-term importance after the session or this communication. That is why sorry. That is why we use a range. We will mention the range of different ports from 0 to 1023. I should mention, I mentioned in the slide. Okay, I see. There are some ports which are well known for specific services. So there are some services specific ports based on UDP and TCP. I will show you a little while. Okay, UDP is unreliable. I already mentioned this connectionless. You know, its header or which is used with session layers data is very simple. This header is very simple. There are four things only: source port, destination port, same as TCP. But there is another length checksum, nothing else. Because in this, for example, you see in TCP there are different formats. For example, sync, ACK, restart, RST, different plugs and window size, which we discussed how window is. There are different fields. All fields may not be comprehensible right now for you, but you have to understand at least source port, destination port, sequence number. They use sequence number. I mentioned all this. Sequence number is important. If you send a TCP segment with a random segment to the receiving device to pull it or to hack the system, it will not accept because sequence number is different from original or initial communication. And then acknowledgement number. Acknowledgement number is also based in sequence number. And window size, which already windowing is used, window size changes continuously. So window size is also mentioned in this. But these are absent in UDP format, UDP's header format. It's clear?
Yes, sir.
Okay.
So a question, sir.
Okay.
So based on the source code and the destination port, we know that the destination port most of the time is just fixed. What of in a case that we have our source code, I add all our details, but the destination port, we don't have any detail about it. How do we send data in such situation?
You mean that we don't know destination port, right?
Yes, we don't know destination port.
Okay, without destination port, it is not possible to communicate. if we do not know the destination port, communication is not possible. It is mandatory. In some case, source port is not used. Communication is possible in case of UDP, but TCP you have to ensure source port also. Okay, source port is assigned by your device randomly from a range, ephemeral port range. Okay, but in UDP case, source port is optional. It is not mandatory, but destination is important, because communication happens in two ways, mostly in client server model or peer-to-peer. If you don't know your peer or server port, you will not be able to send. For example, a standard HTTP port is 80. That is why we don't mention 80. Okay, when we browse, we don't mention port usually. Did you notice this? When we log into a service, for example, if you log into your Facebook, you just enter facebook.com to your browser's address bar. Okay, just hit enter, and the service and web-based service is available to you. So why? Because port 80, actually 80 is not used. It is just secured. It is actually HTTPS protocol. It is 443. Okay, 443. 443 is default for HTTPS. So you just enter HTTPS :/facebook.com. But there is it is implied that it is 443. But there are some web servers which are used for internal use or some specific users. They change the default port. For example, HTTPS 443 is used globally. They just change it to one. What I can say, it is say whatever 843, for example, is changed at the server. So if in that case, if you try to use without mentioning the port, you will not be able to communicate. Okay, clear?
Yes, if you can get my idea here. I mean, like, okay, let's assume we are having two devices they want to communicate, and one device is just having the source port. And what happened is, like, is there any mechanism in which before the source port may establish flow of data? Is there any possibility of the source port trying to gain the detail of the destination port before establishing connection?
No, actually, we have to explicitly mention it. When we say it is HTTP, then it is HTTPS 443. So it is. So let's look at this list, for example. Although there are many ports specified globally. So HTTP 80, HTTPS 443. You have to just know about this. If we take some tests somewhere or you are interviewed, maybe sometimes you may be asked about this course commonly used. So we have to ensure this destination ports in our service request. And if service requests are changed, for example, for SSH, secure shell communication, we use to remotely connect to Linux or Unix machine, or for example, Cisco router, or other Linux based operating system, we use secure shell. But some administrator changed this standard port 22 to different port. For example, they may use 22, for example, 5. Actually, we cannot use all ports because some other ports, there are some confusion will be created. So we'll use different ports considering those issues. And in that case, to communicate with this SSH server, you have to mention port. Okay. Layer 4. One thing I forgot to mention here, that what are the well-known ports, and there are 3 types. Oh, what I mentioned to you. Okay, let's go. I give you a range. 0 to 65,535, for example. These are the range, the total port. Okay. 0 is not used, however. From 0 to or 1 to 1023, it is not well-known port. Why it is well-known port? Because these are the these type of service are specified in this range. And after that, there are some registered ports that are used for some specific service. And then we have a range of ephemeral port range. Ephemeral port range is used by devices when they want to communicate, and source port is assigned from those ranges randomly. Just it is used randomly. And when you establish more than one session, for example, if you connect to a server, then from another browser or same browser, we establish another session to the same server. So we, your PC has to keep track with this session. And 2 sessions should communicate separately with separate source port. All the destination port is same for 2 sessions. So in this way, we establish multi-session to the same server at a time. Okay. So I think these are the issues, although there are so many issues if we study further, but from CCNA perspective, and I think these are sufficient for these layers. Do you have any questions from application to transport layer up to now? Do you have any further questions? Then we move to network layer. I think you are okay. Let's proceed further. Then we have network layer. It is a router, actually. Router works in this layer. Router is used for inter-network communication. If we have more than one network, then routers are needed to communicate. And router creates the broadcast domain. That means we know that there are two types, not two types actually, but mostly two types. Unicast traffic. What is unicast? Unicast is point-to-point traffic, and broadcast traffic, one-to-many. Sorry, one-to-all communication. So sometimes for establishment of communication process, ARP, which we'll discuss later, broadcast is used when a device broadcast, every other devices receive the communication and in this network. So in a network, everybody receives broadcast. But another network will not receive it. So router stands between two networks. So router will not forward your broadcast to other. So it is important because if a device or a medium request different receives different broadcast, it will not efficient way. It will consume bandwidth or other resources, such as when a communication or packet is received, a device is the processor. That is, processor or memory will be used up. So breaking a broadcast domain is important. So router does it. Transform what it is for transmitting end. It receives segments from transport layer, then it transfer it packets by adding source and destination address, which is IP address. And for receiving end, it works in reverse order. Just it receives segments from data link layer and turns into packets. And what are the protocols in networking layer? It is IP version 4, IP version 6, and different dynamic routing protocols. For example, RIB version, EIGRP, OSPF, BGP, etc. What is used? Source IP and destination IP is used in IP header format is shown here. The source IP address and destination IP is added with data link layer packets. So here address means IP address. And I also mentioned different description you can read. So mostly here source address and destination address is added. IP version 4 is you know, I think everybody know. It's 32-bit, 4 dotted decimal numbers. IP version 6 is 128-bit. It is use IP address space. Okay. I hope you know how to assign IP address. What are the ways to assign IP address? We can use in two ways. Manually we can assign IP address or use Dhcp. And I also mentioned how to check the IP address. Okay, do you have any questions regarding network layer?
No, sir.
Can you check your device's IP address
Yes, sir.
Or so my question is how Wi-Fi's IP address is assigned?
Why, sir? Can you repeat the question?
Can you repeat?
Sorry. No,
Can you repeat
not
the question?
HTTP. It is DHCP. You are talking about DHCP. DHCP protocol is used in Wi-Fi router, and from DHCP, our devices get IP address dynamically. So in that case, we don't know. However, if we want to specify IP address to our mobile devices for Wi-Fi, it is possible, but it is not done. Nobody like to do it. And okay. What is actually we actually in this course we will go through in details routing and switching. That means layer 3 and layer 2 will be extensively discussed, but just some idea today is look at this network. It has 3 routers connected somewhere. Okay. There are 3 hosts. One is Larry, Archie, and Bob. If any 2 of them want to communicate, how can they reach? They must go over router. So we can see that we can reach to a host in different routes. For example, Archie try to reach Bob, he can because it is gateway, and then it's internet connection, and then it will go to R2, then Bob. But another way it is possible. The R3 from R3 it will go to R1, then R2. It is possible. So which path is best? Which path is best? It is decided by routing protocol. If we use static route, we can specify it will just go through. Okay, it will just forward the packet. But if we use dynamic route, it will dynamically choose the route through which it should go. For example, if it is Larry try to reach Bob, then it will go to one router 1 to 2, and then Bob. Okay, then we have some layer 2. Layer 2 is data link layer. Data link layer switches work in data link, and switch break collision domain. You know that traditionally we had a shared, actually it is shared medium. Ethernet is shared medium, but in early days the communication face collision when more than one device try to communicate. If they try to communicate at the same time, the will experience collision in the media. That, for example, if two devices send the signal at a time in the same wire, the electrical signals will will collide and it will be meaningless. So some protocol technique was used, but right now collision is avoided using switch for break collision domain. That is why it is more efficient. And layer 2, it is transforms packets into frames. And another point is here is two parts: logical link control and media access. MAC address we talk about. MAC address is a physical address. Every NIC card, whether it is computer, or whether it is Wi-Fi or mobile device, every NIC, network interface card, has its media access control. Let's 6 pairs. Its address range is here. It is hexadecimal number. It is unique actually, although there are some different some exception. So MAC address is fixed for your device. Normally, it is not changed. So broadcast domain, is a switch, reception broadcast. All the devices connected to a switch receive broadcast. So how can you check your MAC address? Can anyone tell me?
Yes, by going to command prompt and write ipconfig/or, then you get all the network information.
Yeah. You will get MAC address of all the NIC cards. Correct. And how can you see your MAC address in Android or iOS devices?
Going to a network setting of your device. System setting.
Yeah, in system setting, you will get a connection, so network. Then you will go to Wi-Fi. Okay, you will get. Yes. Okay, which is what is happening in layer 2. In layer 2, how transmission is possible? It for transmitting device, Ethernet header is added to a packet. It receives IP packet from layer 3 and add a header. It also add trailer. Actually, it adds some overhead both end of the IP packet and send it to the destination. Destination system, it discards or de-encapsulate IP packets. Just receive IP packet and it discards Ethernet header trailer. So for receiving this, it happens opposite. And this way, it transmits. We will discuss further about encapsulation and de-encapsulation in a separate session. It is very important. Okay, although we completed 2 hours, but I will try to complete very soon. I think we should complete. I will go through as quickly as possible. And layer 1 is another important area. It just transmits bits. The physical medium I already mentioned. You can just go through this material. You will get here in physical layer, hub repeater modem cables are used or working. There are three medium, copper cable, and then we have fiber optic cable, wireless radio link. We have different types of cables. You will here Cat 5, Cat 6, Cat 5 and Cat 6 has up to 1 Gbps capacity, and Cat 7 nowadays are not commonly used. It can carry up to 10 Gbps. And another two types of UTP, unshielded and shielded twisted pair. Unshielded is cheaper. Unshielded means there is no extra mesh shield to protect electromagnetic. You know that if we put Ethernet copper cable very near to power cable, sometimes it receives electromagnetic interference, which can hamper your communication or sometimes reduce bandwidth. So STP cable has some special mesh shield which protects you from electromagnetic interference. It is costlier, so it is not commonly used. UTP is commonly used for internet connection. Most places you will see it. And these are the connectivity. Your net card, you know about this switch, then connectors, RJ45. And for optical fiber, SFP, SFP plus connector is used, and cable is used. You know that fiber optic cables are used in a high performance network connectivity and provides you higher bandwidth. So there are two types of cables, fiber cables, single mode and multi-mode. Multi-mode is for short distance. For example, you have ISP and to your home or your small office or office connectivity. For your long distance communication, and you have to use single mode, which is more efficient and can carry data to longer distance. So these are normal connection scenario. In simple term, computers are connected to switch. Switch is connected to router. Simple network, although we have different topologies. It's vast topology. Ring is like ring, and the star topology like a star. Different topology, you will just understand. Another important concept, half duplex and full duplex. Simplex connection. You know that some connection is one way. For example, radio, terrestrial radio, just a one-way communication, like that. But simplex communication is not used in our computer network. Half duplex is used in legacy technologies where one transmission and can be done and reception is done later, or we cannot do both concurrently. And full duplex, right now we have full duplex capacity in most networking devices. So full duplex can communicate in both ways, sending and receiving is possible at the same time, and our switches are able to communicate this way. But in old devices that are half duplex sometimes. What happens in collision domain? There are two devices, Archie and Bob, both are trying to communicate, and they collide. Okay, they try to communicate. Larry and collide. That is a problem or inefficient. So to avoid this, the carrier sends multiple accesses with collision detector. CSMS-CD is used in that case. In this type of protocol or system, at first you have to look at the transmission medium. Just like when we try to cross the road, we check is there any vehicle or anything else. If we see it is free, then we cross. Just same concept, but it is inefficient in the sense that you have to wait that channel is clear for you. So you have to delay your communication. And full duplex, you see that hub is used and the right side device. It is hub duplex, so you cannot communicate, send and receive at the same time, but you have switches, you can do that. So it is full duplex. Okay, we have to prefer lab environment so that we can configure router and switches in lab environment and we can practice. Although in person lab session, people work with routers and switch, which are physical device, but in Cisco packet tracer, which is simulation tool, is exactly the same commands or software or OS used. So you will not face any differences. Moreover, it has some advantages. You can design different network scenarios and communicate. But in real lab environment, you may not configure different networking topology. So that is constant. But in packet tracer, you have more advantages. Have you used packet tracer earlier, or do you have any experience with packet tracer or any simulation device?
Yes, all of us.
Do you have installed it on your computer?
Yes, sir. Sir, Cisco packet tracer were installed in our computer in before.
Okay, great. That is, we from next session we will keep some lab sheet for practice, and you will practice run the commands and then verify whether your commands are working or not. If anyone have no experience with packet tracer, I have given a link of Cisco Networking Academy. From here you can download the latest version packet tracer and install on your computer, and we will practice lab next session. Okay, do you have any question or anything?
So, sir, in the next class, we are going to our lab.
No, actually, we will discuss different things, and at the same time, we will perform some labs relevant to our discussion. So, for example, when we discuss about switch, then we will practice with switch and computers so that we can establish a switch network, and you will learn more about switching. Then we'll other areas routing, and this is way, and this way we will practice and hope everybody will clear concept and develop your knowledge further. One WhatsApp group may be created, so you can, if you have any questions, you can put your question there, and everybody can see and discuss everybody. So I encourage you all to discuss if some questions or issue arises, so that we will learn from him or her. It is great for learning. And if you have further questions or anything else, ask, or we will close to the session.
Sir, one thing.
Okay.
Sir, in the beginning, you asked us what the expectation that we do have from the training.
Okay.
So we could not get time to explain well what we are hoping to get.
Yeah.
Actually, from like for example, from today's class, we found that 90% of what we've done today, we have all of us we have already done it.
Yeah.
So we do have basics from theoretical aspect on networking. So I think that most of us, the expectation that we are waiting is the practical. If we can, if all our session can be 90% of practical, I think that should be more benefit.
Okay, it's great feedback from you. Actually, I was not sure about your knowledge level right now. So I just prepared this material based on my idea, which I thought that you need some basic. And as I found that you have some basic knowledge and you know something theoretical base you have. So we from next day we'll focus on practical part, and we'll just give some theoretical discussion for short time, then we'll proceed to lab environment. And for this, make sure that you all have lab environment ready. I think packet tracer is enough for this course. So everybody make your lab environment on your computer. If you face any problem, take help from your peer, or just you can also take help from me. I think that you will get packet tracer latest version so that we can practice in the next session. Okay. Do anyone else have any other idea or feedback?
So the class is very interesting.
Okay.
So, more, I have one question for this.
Okay.
Company registered with Cisco?
Yes. You are asking, we just focus on Cisco.
No, I said that does your company register with Cisco Networking Academy?
Sorry, I am not clear about your question. And do you mean that different companies use just Cisco or other?
No. I mean that is your company registered with Cisco Networking Academy?
Sorry, Cisco.
In each country, there are many networking academy that is registered with Cisco. So what I mean here, after our training, are we going to get a certificate from Cisco?
Cisco certification. You are talking about how to receive a Cisco certificate, right?
Yes, sir.
Okay. What you have to do to receive Cisco certification is to prepare yourself for the test. Then you register at Pearson Who. You know about the test center. Test center are available in our country and every country across the world. And after registration, you just sit for the test. And this is the process of certification.
Okay, sir. So after this session, are we going to get a certificate?
Oh, just for training?
Yes, sir.
Of course, you will get a certificate as you are participating in a training course. You will get a certificate of completion or attendance. So, of course, you will be provided.
Okay, thank you, sir.
Okay. Do you anyone else have more questions or? Okay, let's finish today's session. Okay, thank you all for participating.
Thank you. Assalamu alaikum.
Thank you, sir.